Okay, let's begin. Today is a really exciting day for us in this class because we're finally, you take a class intro to games, and we're talking about the World's Fair. We're talking about penny arcade machines. We're talking about card games, Kriegspiel, all this stuff. But now we're finally at the point where we can talk about a computer with a screen that has lights on it that you can control, right? We're finally at that part where we can actually talk about video games. Finally, we're here at last in week 5. We get to talk about the first video games that were ever made. So let's do this. We're finally here. Okay, so Spacewar. Now, when you dig deep into this, you'll find that there's some other sort of games that were made that maybe might be before Spacewar. We're not terribly sure, although some of those games were extremely primitive, and I'm not sure they fit the definition of a video game perfectly. They were more like, in some cases, they were like demonstrations for certain types of scientific instruments that had monitors on them and things like that. So I still think, despite that subtleties to this, saying this is the first video game, fairly accurate, okay? Spacewar. So let's get into what that was. So you saw young Steve Russell in that slide. Here is older Steve Russell here. And he was at MIT in 1962. Now, he developed Spacewar on the PDP-1 computer. During its time, it was considered small and cheap. So that you can see on the screen is what a small computer was then, almost the size of a small car. And cheap meant $120,000. This was a small and cheap computer in 1962. Again, just to give you some perspective, okay, on how far we've come with computing and how accessible these devices are. And of course, really you could only access them in the early 60s as part of a university or major corporation. Now, the PDP-1 had something really special about it, other than being this, wow, this is small, and wow, this is only $120,000 in 1962 money, okay? It had a monitor, and if you look at the picture there with Steve Russell with the white gloves, you can see the monitor kind of behind him in this picture. So one thing that I kind of want you to understand, because I think it's cool to realize this, is we take for granted the coupling of computer graphics with the computer itself, right? We totally take that for granted. We think a computer must have a monitor. Monitors, computers. In fact, my department here at Purdue is the Computer Graphics Technology Department. So it's important to understand that in the early days, a computer didn't necessarily have to have a monitor. In fact, you see here with this PDP-1, there's this little typewriter thing also attached to it. That was the more common way a computer outputted data to the user. It would print stuff out. There would be no monitor on a lot of these, right? You would just get printouts, right? Or maybe you would just get lights that you'd have to interpret. This was also true of the first home computers in the 70s. Some of them did not have monitors. You just would look at computations on a board of lights or whatever. So the idea of computer graphics was itself a separate innovation from that of a computer. Now, I suppose you could say that it's inevitable because a computer has to display data. We have to use something, right? But I think it's just interesting to point out, not necessarily automatic that computers had computer graphics, and that's kind of what made the PDP-1 special. Okay, so let's talk about the design of Spacewar. Now, if you played Asteroids, this will be sort of familiar. Asteroids is kind of a single-player later iteration on some of the ideas established in Spacewar. So you have 2 ships. You can kind of see them here in the upper left and upper right of the play field. And you rotate these ships. And they have thrusters, right? And it's not that kind of way game characters are controlled typically now. It's this inertia idea. Again, that's why I reference Asteroids. If Asteroids, you have a thruster button, and the ship kind of has inertia. Like when you let off of the thruster button, it will just keep drifting. That's kind of how the ships operate in Spacewar as well. Now, one thing, it's kind of hard to see or to tell really, but this is a a star in the middle with a gravity field, and if you get too close to that gravity field, you will be destroyed. Uh, Utterly destroyed. So you have to avoid the center. Now, you can also use that gravity field to kind of slingshot your spaceship around the screen. So you can use that in kind of smart ways. But if you get too close, it is, of course, death. And the spaceships do shoot torpedoes. You shoot them at each other. And really, we get the first example of sort of iterative game design here with this, because initially the torpedoes had some variance. In other words, he was concerned with emulating real torpedo behavior, that they're not always going to take exactly the same flight path. There's various things that might differ when they're fired out of any kind of craft that fires torpedoes. So he tried to emulate this realistic behavior, and guess what? Made the game less fun, right? So he removed this. He removed the erratic behavior from the torpedoes. And I feel like that's one of the first in computer game design examples of a design iteration that we can point to, where something was built, it was tested out, found not to be fun, change was made, now it's more fun. So I think that's super cool. And I refer to it in the slides as maybe the first example in games of something I like to call service to the player. This is kind of a concept I've been sort of personally developing over the last couple years, this idea of when do you break with realism in computer game design, or break with immersion in order to benefit the player in some fashion. I call that like servicing the player here. So we service the player in this example by removing something that makes it like a realistic simulation, and instead we replace it with something that actually is more enjoyable to the player. And I personally call that service to the player. And once you download the slides, Spacewar, you can find, a link here. It'll take you right to a web app, and you can try it out yourself if you're so inclined. Okay, so Spacewar is not a commercial product. Okay, so this was made really because these early computer enthusiasts were just excited about the technology and liked making things and liked making creative things with this really brand new frontier, right? So this was done as open source. Anyone could contribute. Now, it wouldn't be long before someone would realize the commercial potential in things like Spacewar. And now we enter Ralph Baer and the Magnavax Odyssey. That is, Ralph Baer is an older gentleman there with some prototype versions, not the finished product, but some prototype versions of them. So let's talk about the Magnavax Odyssey, which is the first commercial video game product. Now, one thing I'll say I think that's really cool is we usually think that the first video game commercial product is Pong, but it was actually this. It was actually a home console. A home game console was actually the first commercial product. So that's kind of interesting. You would think it would be an arcade product, but it was not. It was actually a home console. It was developed in 1967. Even though it's called the Magnavax Odyssey, it was developed at a company called Sanders Associates. They were like a defense contractor. They worked in all sorts of technologies, and Ralph Baer was an engineer there. And the experiments were very crude. I mean, we're really talking about, with the Magnavax Odyssey just in general, we're talking about really just a machine that lets you, in a very rudimentary way, control a couple of lights, right? I mean, we're really talking simplicity itself here. And as a consequence, Ralph's bosses didn't really see the potential in this right away until, and this goes back to this theme I keep saying again and again, we just like shooting things, okay? We really love that a lot. As soon as he found a way to create a game in which you add some plastic rifle and you're shooting a light on a screen, then the powers that be were like, yes, we understand. This has some potential. We should do something with this. Now, Ralph needed a designer. Now, game designers didn't exist, right, as a discipline, video game designers. So really we're talking about someone with the creative ability to realize interesting applications of this new technology. Ralph Baer was a fantastic engineer, but not necessarily someone with a design mind. And he understood this. So he brought on board this gentleman here with the big thick tie and the glasses, Bill Rush. And, Bill Rush, he was sort of one of those absent-minded professor types, if I may use that stereotype, and, one of those creative sort of people that just kind of gets under your skin, a little eccentric, right? Kind of late to things, just, the professionalism not always there. Now, I encourage you all, don't take the wrong lesson from this, be professional. But what I will say is I think the video game industry has always been very good at handling people like this compared to other avenues of life. We do care about the output, the quality of your work a little bit more than the sort of day-to-day, are you crossing all the T's, dotting all your I's, right? And a good example of this is the concept of core hours, which probably exists in other industries too, I imagine. But in the video game industry, we recognize it's not like a retail job, right? Retail job, you go and if the store opens at 9, it actually does matter if you're there at 9:05, right, or 9:03. There might be customers not being served. That's why that type of employment is like this. Someone's going to be pretty mad at you if you're always showing up at 9:03, 9:04, whatever. In fact, you'll probably get fired eventually. Video game industry is not like this. I mean, there is a retail side to it, but that's not the part we're involved in. We're involved in making the product. And honestly, no one cares if the effort to make the product was done at 11 a.m. to 2 in the morning, or if it's done perfectly from 9 to 5. It's just as long as the work gets done. So that's why we have this concept of core hours, which I bring up now because Bill Rush and sort of his eccentricities reminds me of this, where you might say, okay, look, 4 hours at the studio is 11 a.m. to 5 p.m. This is the time we need everyone to be in the building at the same time so we can do things like have meetings and stuff, right? But the rest of the 8 hours that we expect out of you, we kind of don't care how you get those 8 hours in. Just be here for this core set of time. And game developers, they all have different concepts of what core hours is. Actually, it's funny, Cold Iron, their cold hours was basically just 9 to 5, right? Like some companies, the core hours is just like a regular job. But most of the other places I've worked at or with, they actually do have this idea of like, well, look, some people get to the office at 9 a.m., some people get to the office at 11, and that's fine as long as the work is getting done. So anyway, Bill Rush, kind of eccentric, but Ralph Baer was a great manager. Because one of the things about great managers is they recognize talent and they're willing, in my opinion anyway, to work with that talent, not against that talent. So I think that's a really great example of excellent management on his part. So he added some design creativity. He found more interesting gameplay ways to create fun out of this primitive technology. Now, like I said, we really shouldn't, and there's an older Bill Rush there later with another iteration of a Magnavax product there. We shouldn't overstate the eccentricity, right? We should all strive to be professional, all right? But again, like I say, I really admire Ralph Baer handling him well because I think that's a really important part of being a good manager. You folks out there that are going to be producers, you'll understand this as your career progresses. So an example of this talent being nurtured here is that Bill Rush had this passion project where, a guitar was hooked up to some kind of computing device, and he allowed him to work on this side project, right, while working on the Magnavax Odyssey. Again, this is just a small way in which, again, this particular talent was nurtured. Okay, so one of the things that Bill Rush came up with the primitive Magnavax Odyssey technology was hockey. He figured out that we can take this system that, again, really could just only make a few lights that blinked, okay? I mean, really, it's so primitive. He figured out that we can make a pretty decent hockey game out of this. We can basically use a couple of the lights for paddles, another one of the lights for a ball. Now, one thing they did have to change is they did have to have a ball that could move on its own, which the Magnavax Odyssey in development could not do at this point, right? At this point, there was nothing that can generate any sort of artificial intelligence. Remember, we're not even at the point where CPUs are available. So all of this stuff was going to be hardwired logic, no CPU, no central processing unit yet. Okay, so just to have a moving ball meant they had to, sort of hardwire that logic without the aid of a CPU doing like computations and things. But they were able to do that. They were able to get the circuitry in there for a ball to move on its own, and that kind of gave the minimum amount of technology for like any kind of interesting game to happen at all. So when we look at the controller, that's another thing I want you to appreciate. Look at this thing. Just like the meme. Look at this, right? Uh, so that controller looks nothing like any controller you've ever used, right? On a Nintendo, a Genesis, a PlayStation, whatever. That doesn't look comfortable at all to hold, like for even 10 minutes. Now it was designed to like be on like a desk or a flat surface. I think that's kind of what they had in mind for it. But yeah, there is no template here, folks. No template. No guide to this. No, well, geez, look at Nintendo. They made the most comfortable gamepad. Let's do that. Nope, there was none of that, right? They were flying blind. And when you're flying blind, you're going to get these sorts of things, right? So what you had is you have these two knobs that can move something horizontally and can move something vertically. You do get a reset button to reset the game. And then this little outer knob is kind of interesting. They call this the English knob. And what that was for, and you'll see this, we're going to look at a TV advertisement for the Odyssey, which I think is incredibly delightful to watch. The English knob basically lets you control the movement of the ball. Like imagine a tennis game, right, where you hit the ball and can just, with your mind, move the ball around. That's essentially what the English knob does. They were thinking of English like playing pool, like applying spin to the ball. That's where that term comes from. Uh-oh, what just happened? This is one of those things where WebEx is being weird again. Let me make sure I'm still live. WebEx folks, am I still coming through?
Yes, sir.
Okay, yeah, WebEx just did weird stuff to me just now. Sorry about that. Okay. Okay, so now we're at go away. Now we're at the commercial release of the Magnavax Odyssey. Okay, so now it's called the Magnavax Odyssey because that's the company that Sanders and Associates pitched this to. So, and here's what it looked like. Okay, now it's easy to think that these are cartridges here. Now, notice these little things here on the bottom, and yes, you plug them in, and they do allow you to play different games, but they're not cartridges. Well, they're not cartridges in the way that we think of them. I mean, technically, I guess if you define a cartridge as something you plug into something and it changes the thing, then yes, but not really. The reason is all these cartridges are doing is just changing how the internal logic functions on this machine. There's no software on these. Okay, there's no ROM image on these cartridges. So all it's doing is just instructing. It's just redirecting the circuit a little bit, right, to create different effects, to create different gameplay effects. So that's how those things are working. So it's not as robust as the Fairchild Channel F that we'll talk about later, where it actually is a piece of software, computer code with instructions. Remember, there's no CPU here. There's nothing to instruct, right? This is just circuitry and electronics being used in a clever way. And again, so those little things that you plug in, they just kind of change how the system operates. It's not software. So we don't consider that the first cartridge-based system, if you were curious about that. Okay, so it was released through Magnavox television dealers, and that actually created something of a problem because it wasn't required that you had a Magnavox TV, but many people thought this because it was sold through Magnavox dealers. And when I say Magnavox dealer, if that confuses you, back in those days, you didn't buy televisions at Best Buy or Walmart or Target. You actually bought them from, TV dealers, like a car dealership, but televisions. Like this was something that was still kind of around a little bit when I was a kid, but it was already, going away rapidly. But yeah, in the 70s, you wanted to buy a Magnavox television, there'd be a person with a Magnavox TV store. Okay, so again, just one of the many, many subtle differences between early 70s and 2021. So it debuted at $100, which would be like $630 today. So, certainly expensive, not, completely, out there. But yeah, pretty expensive, pretty expensive. So when we try to understand this first game console, we do have to understand how much we take for granted. So when we look at the video for the Magnavax Odyssey, and actually I think you do have a lab, hopefully it won't be the lab that has to get axed for the test, where I actually ask you to design a Magnavax Odyssey game. It's okay, this is really primitive, right? Yes.
I actually watched a history video on this
Yeah.
years ago.
Yeah.
It's a system that they don't even have graphics. You just have like these plastic covers that you slap on the TV.
Yeah, the question was, is there no graphics, just plastic covers? There's both. What you have is you have basically three lights. Okay, you get like three lights in like a line, and what they would do then to try to create the semblance of more is there were plastic overlays. Yeah, that would go over top of. It's like a static thing that clings to the television screen. Which again, that's another thing. Like most TVs were around the same size, not something that you could assume today at all now. But yeah, like the Odyssey is an amazing feat of engineering. Yet it cannot do hardly anything of the things we take for granted. Okay, so again, it could display three dots. Okay, a dot for each player, and then a dot that the system could move around, and a single line. So three dots and a line. It's all it can do. Okay, all it can do. No audio, no scorekeeping, because again, that would require a lot more brain power than this thing could have. No color. All right, and like I said, this is not a cartridge system, so yeah, so really interesting limitations here. All right, so let's take a moment here and watch, and hopefully this YouTube video still exists, the first Magnavox commercial, the Magnavox Odyssey commercial. And sorry for any ads that are probably going to come up here. Yes, right, yeah.
Who are content to let television do its thing, often find themselves at its mercy for a choice of entertainment. While people who want television to do their thing, entertain themselves with Odyssey. You like to play game of the future and world of a thing. Odyssey intends to any brand television receiver with screen size of 18 to 25 inches.
Notice how they have to tell you exactly how to install it, right?
A screwdriver is the only tool needed to attach this Odyssey antenna gain switch to the antenna terminals on the back of the television set. Once the antenna gain switch is attached, you can select the TV position for regular television viewing or the game position for playing your favorite Odyssey game. Odyssey is played through an unused VHF channel of your television set. It operates on 6 common-sized D-cell batteries.
Yep, not plugged in, battery powered.
Beam cord to the antenna gain switch on the back of the set and to the master control unit. And plug the player control unit cords into their respective sockets on the master unit. And your Odyssey is ready to begin entertaining your family. Each Odyssey game uses one of these special game cards, plugged into a slot at the front of the master control unit. The game cards activate lights on your television screen that bounce, float, or extinguish on contact. Depends on the particular game you've chosen to play. For example, to play Odyssey tennis, you insert game card number 3 in the master unit. This activates 3 lights, 2 representing the players and 1 representing the ball. Press the special tennis game over in the position on the television screen, and you're ready to begin.
Look at those graphics.
Player control unit allows you to move your player right from the left to right or right to left direction. On the right side of each player control unit lets you move your player right in an up and down direction. And the reset buttons on top of each player control unit bring the ball back into play should it happen to go off the court. The basics of the game. You can increase the challenge of Odyssey tennis by increasing or decreasing the speed of the tennis ball with a special speed control on the back of the master unit. And And when you want to razzle dazzle your opponent into submission,
This is such a cheat.
make that tennis ball do everything.
Just like real tennis. Yeah. Yeah.
And someone threw a line bomb.
Now I'm going to stop it on cat and mouse because it is important to kind of understand like kind of what's capable here. So what you notice is that in cat and mouse there is this collision detection happening where where like one player light can cause the other player's light to turn off. So that's we can kind of add that to our list of things that this console can do, right? So you have the ball can collide with the player light, so the computer controlled light can collide with the player controlled light. So you do get some simple collision going on here. So that's kind of important to remember. I'll keep it going.
And Simon said, the image of Odyssey game series as a challenger the submarine. Roulette, Analytic, and Geography. Each Odyssey game comes complete with all equipment necessary for play, whether it's one of the 12 standard games or one of several optional games, which include a special shooting gallery.
There's that gun. And so again, in 1971, 72, this would have been mind-blowing, right? You did have the ability to shoot this gun. It probably uses the same light sensor that an NES zapper would use, and it would cause that computer-controlled light to disappear, right? So you actually get a reaction to aiming something at a particular spot on the screen. Pretty nifty for 1972. Pretty nifty for no CPU.
Separate compartments designed to hold all games and equipment. They make setup of read and storage or moving of your Odyssey unit to your pleasure. Odyssey can be many things to your family. Fun, excitement, entertainment, talent, and education. Why not take one home with you today? It's available only from the Magnavax salesman in the store. Odyssey, the electronic game of the future that lets you do your own thing on television.
Yeah, and I want to make a comment about that remark in the ad, right? It lets you do your own thing about television, with television, because I feel like that's an element of video gaming that's been lost now or taken for granted. When I was little, video games are still new enough that I really felt this idea of it's the TV, but I'm controlling what's on the TV. Like there was a magic to that, I think, in the early days that now it's just like, again, we just totally take for granted. Well, of course you can control and interact with things on the television, right? Even things like modern DVD players, Blu-ray players let you do that. So, this idea of you have this completely passive device, and now we can actually ourselves interact with this passive device was, mind-blowing, right? Absolutely mind-blowing. And it still kind of was, I think, in the mid 1980s when I was starting to get old enough to because I was like 5 in 1985. So that comment I kind of wanted to highlight here. So the other thing I'm going to talk about in this video is just a brief explanation of how some of these games functioned. I feel like the shooting gallery is fairly self-explanatory. The computer-controlled dot's going to move across these overlay positions, and so obviously when the dot's moving across the airplane row, it's an airplane, right? Like, it's just illuminating those airplane parts of the overlay, right? So, oh, this is a rabbit now. This is a duck now, right? This is, I guess, a warship or something. So again, how the overlays work. Some of these games really require a lot of imagination to do well. I think the way the Simon Says work is you do have like cards, like physical cards that are telling you like where to put the dot, right? And so one player would say, Simon says, left hand, and you would move the dot to the left hand, and then another card would just say right hand, right, and you'd lose if you moved the dot, right? So that's one thing about these Magnavox Odyssey games that are very interesting to me. The amount of real world materials they required and overlay actual playing cards. The other thing about Magnavox Odyssey game design I find really fascinating is how much honor system stuff has to happen, right? Because when we think about even its kind of flagship game, the one game that I think most people remember from the Odyssey that were alive at that time is your basic tennis game. Even that had no scorekeeping, right? So you had to keep score. That was you doing that. So there's this honor system element. There's this element of the computer isn't completely doing everything for you, right? Like, it's not taking care of all the aspects of the gameplay. You're still bringing quite a lot to the table. And so you kind of get with the Magnavox Odyssey this combination of board games, of parlor games. Again, we can really see this connective tissue between pre-video game games, pre-video game prehistory, when we talked about parlor games and card games and all this. A lot of those techniques still have to be used because the Magnavox Odyssey can do so little, right? So you have to bring a lot of other things to the table to make these games function. And when we look at games like some of these games are just impossible to foresee how they would be, doable. I think that let me scroll through here and find another example here. There's the submarine one, which is kind of interesting, although I'm having trouble queuing that up exactly. I think it was somewhere around here. I'll just hit play and stop when I get to it. Now, again, football, it's going to be real abstract, right? It's very abstract. I'm not even sure how. There's awesome YouTube videos, by the way, where people go really deep. In fact, the University of Pittsburgh, I think, they have like a club where they just make new Magnavox Odyssey games. So people really get into this with this primitive technology. But like the basketball game, I know how that one works, where basically you try to make the moving light go into the hoop. But you have to call your own fouls, right? Like, Magnavox Odyssey's not detecting that, right? You have to again, so much of the gameplay is honor system and you following the written rules correctly here. And with cat and mouse, how that works, again, is one player is the cat, the other player is the mouse. And when the cat light touches the mouse light disappears. Now, look at what someone tell me in this. What's the kind of honor system element to this game? Yeah, that's right. You can go anywhere you want, right? You don't have to obey this level design. Like you can just go through all of these walls. Now, obviously, what's going to happen if you're playing that with a sibling at home on a rainy day, like they depict in the ad, you're going to yell at your sibling, right? You're going to, maybe even things might get a little physical like they sometimes do with brothers and sisters. Not advocating that, of course, but obviously the other player is going to call you out, right? You dirty cheater. But yeah, the computer's not helping you much with this, right? We really take that for granted now. The fact that, in a modern system like in Unreal, we can duplicate this in minutes in Unreal, right? With like a real physical representation of the maze, the idea of one player block touching another block and making it disappear. Easy stuff to do, right? But back then, wild technological innovation. But I think there's something really, and why I love that Magnavox Odyssey lab exercise that you have coming up, is there's something really helpful about designing for such a limited set of capabilities. It makes you think a lot harder. I think there's a certain type of creativity that you get from strictly imposed limits, right? So, and I will say, if you go to that, I think it's University of Pittsburgh, if you go to their, if you just type Magnavox Odyssey new games in YouTube or whatever, you'll eventually find them. And they actually come up with some really clever ways to manipulate this technology by adding certain devices to it and whatever, which I don't allow you to do, by the way, in the lab exercise. You have to stick to the things that the system can actually do. But it's fascinating, right? And so how did the Magnavox Odyssey do as a product? It did okay. It did not light the world on fire, though. It wasn't a runaway smash hit. It was only a commercial success, as we'll find out in next week's game history lecture when we get back into game history, when Pong comes out, because Pong is very much based on Magnavax Odyssey tennis. And even though Nolan Bushnell denies this, it later came out that no, actually, it was totally based off this. And so once Pong kind of made this popular, more people went back and bought the Odyssey. It kind of gave it a second life. But it was initially released. It was expensive. There was this weird thing of you can only buy it at a Magnavox dealer, and people thought it would only work on Magnavox televisions. And of course, it is of limited capability. I have to imagine that when you think about the people that decided how to make this ad, so much of this ad is dedicated to like, what the heck do you do with this? So, faltering first steps, but still really cool. Still a really important kind of first step in the development of video games. Someone had to take it, and Ralph Baer and the folks at Sanders & Associates did that with this. Okay, folks, we're done. I'll see you all later, and thank you.